Wait, but how do we know what's the question?
Can't you see the question?
It doesn't pop up. It's just the triangle, the red, blue, orange, and green.
The question is there. I don't know why it's not. Oh.
I don't have the question.
You can't see the question?
No.
Are you the only one who doesn't see the question, or everybody?
The thing is, she's doing it through her phone, the meeting, through her phone number and not through the app.
Yeah.
She's not. She can't see the screen.
Oh.
Yeah, I'm doing the meeting on the phone.
Oh. How do I do now? I don't know how to do on that because. But with your phone, are you using the app?
I'm using the phone because the app doesn't work on my phone.
Oh.
Yeah, that's
the
why
question
I'm using
is,
it.
what is the appropriate percentage by mass of carbon in KH03? I don't know what you. But you can see my screen, right?
If I what?
Can you see my screen?
No, I can't see it.
Oh, you are using
the phone.
Only
like the
audio.
Phone
You're only using audio.
Yeah, audio.
No, there's no way you can do that. You have to be video.
Yeah.
You cannot participate if you cannot use the audio, your video on your phone. Don't you have a camera? Is you able to use your phone, your video on the phone?
Yes, because I would use my sister's computer, but she's doing her work right now.
Diana, just download the app. And
yeah,
then
you can use your phone.
able to through it like that, and then
All right. Okay.
All right, we have KH03. We're looking for the mass of percentage of carbon. So your potassium is 39 plus hydrogen, which is 1, plus carbon 12, plus oxygen, which is 16 times 3, give us 48. The total will be what? I think it's about
100.
100, okay, good. All right, so but we're looking for a percentage of carbon. So carbon is 12. So that will be 12 over 100 times 100%. And that will give us 12%. That's how we got that from, okay?
My forehead, no, the one that has your name.
All right, let's move on. Try to mute your audio.
Okay. How do you do that? Mr. I don't know how to mute the audio.
You see, it's like a microphone.
Press the screen, and then it'll pop up on mute.
Yes, you see the microphone there. Ooh. All right. Let's see what happened. What is the mass of 8.12 times 10 to 23rd molecules of CO2 gas? Atomic mass of carbon is 12.01, oxygen is 15.99, All right, let's go back to the class. This is what you are given. You're looking for the mass of CO2. Now, once you have something like this, what comes to your mind? Molecules of CO2. So that means 6.02 times 10 to 23rd molecules. CO2 should come to your mind. Once you see anything like this, then you know you are going to use Avogadro's number. And this is 1 mole of that carbon dioxide. All right? So the next thing to do is to, let me shift my camera. Next thing to do is to, now let me write it this way. Is to, this is mole of CO2, to find the mass. Mole of CO2, moles of CO2 here will cancel this mole. Then once you have mole of CO2 here, since you don't have any chemical equation, so there is no mole ratio. If the chemical equation is there, then that's when you go to your mole ratio. But there is no chemical equation, so it's just the mole to mole. So you have mole of CO2 here, then you have mole of CO2 here, which is 1 mole. Because you're looking for mass, so that means you look for the mass of CO2. That's why you are given the carbon is 12, oxygen is 15.99. I will just use 16. 16 times 2 is 32. 32 plus that will give us 44. So this is 44 grams of CO2. All right? So the next thing to do is, okay, mole of CO2 will cancel mole of CO2. The only thing you have left is your grams of CO2. That is what we're looking for. So what you do is to multiply this by this, divide by this. Now, if you look at this, 1023, 1023 are common. So I can just cancel that, top and bottom. Then what I have left is 8.12 times 44, divided by 6.02. So I will use my calculator. I have 8.12 times 44 divided by 6.02, and that will give me 59.3 grams of CO2. That's how that should be done. All right, let me see if we can. Okay, camera. All right, that's better. Okay, any question on that? That's 59.3. All right. At STP, 1 liter of hydrogen and 1 liter of helium have the same number of molecules. The same number of molecules. That's what should be. Same number of molecules. None of you got it right. You're saying number of atoms, number of density. It's number of molecules. Number of atoms will refer to hydrogen is 2 atoms, that is H2. Helium is 1, that is 1. So they don't have the same atoms. We're not talking about Avogadro's number now. We're talking about the number of atoms here. Hydrogen is 2. Helium is 1. So they don't have the same atoms. They don't have the same density, and the mass, of course, is not the same. But this is 2 grams, and this is 4 grams. All right? There you go. Okay. All right, let's work it out. All right, that's better. Okay, we have 54 grams of water given to us. This is the balance equation. Now remember, when you're working on this stoichiometry, I said whatever you have here must come down here. So grams of water will be here. So what comes to your mind is, if you have looking for grams of water, you have to look for the mass of H2O. So hydrogen is 1 times 2 plus 16. That will give us 18 grams of hydrogen, of water rather. And this is 1 mole. Anytime you're looking for mass, it's always 1 mole at the top, always 1 mole, or top or bottom, depends on what you're doing. Right, the next thing is grams cross grams of water. This is mole, so the mole will also be here. This mole of water. Now, because you have a balance equation attached, there must be a mole ratio. Okay, so this is mole of water down here, because this mole of water I have to cancel out. That is the conversion factor. So in this case, the mole of water in the water balance equation, is that the equation? So that means, oh, this is, okay, they have different states of, hold on, let me go back to the question. Did I copy the question correctly? Oh yeah, it's hydrogen, sorry. It's hydrogen. So, mole of water is 2 H2O. That is 2 grams, 2 moles of that. We're looking for how many grams of oxygen? Okay, we're looking for oxygen, right. So we're looking for oxygen. So mole of oxygen will be right here. That's what we're looking for. And that is 1 mole, because 1 mole on the mole ratio. Okay? So mole of water will cancel mole of water. You have mole of oxygen right here. So you must have mole of oxygen right here as well. But this time around, you're looking for mass, because this is grams to grams. We're looking for mass. So what is the mass of oxygen? Oxygen is 16. Because it's there atomic, that will be 32 grams. So that mole of oxygen will cross mole of oxygen. So the only thing you have left is grams of oxygen. So what to do now is to multiply 54 by 1 by 1 by 32, divide by 18 by 2 by 1. So I will advise you do it step by step. Don't just put everything together in a calculator, so that you don't mix up the whole thing. So what you have is 54 times 1 times 1, 1, 1, then times 32. That will give me 1728. Divide by 18 times 2, which is 36. Now equals to 1728 divided by 36. That will give me 48 grams of oxygen. That's how to do that. 48 grams of oxygen. This is mass to mass. You start from the mass, you end up with the mass. Remember, if you have a balance equation, then there must be a mole ratio section. If you don't have a balance equation, this section is not going to be there. Just take notes. All right? So that is how we got this to be 48. Now, which samples contain 1 mole of atoms? If you look at sodium is 13 grams. That is not 1 mole because a mole of sodium contains 23 grams. A carbon supposed to be 12 grams for 1 mole. Potassium supposed to be 39 for 1 mole. If you check your periodic table with krypton, that is 84. Remember, you have to be with your periodic table at this time because stoichiometry has to do with periodic table, where you look for the mass of the substance. All right? So make sure you have your periodic table with you, or you get your textbook. The textbook has a periodic table at the back page. There's always a textbook on any there's always a periodic table on any chemistry textbook, and it usually is at the back page, the last page of the book, the back cover. All right? Wow. Who missed it?
My time was up. I was about to click it
You
and
have
it
to
was taking
work
forever.
fast. You have to work fast. This is a simple one step.
I know it was just adding it.
This one
But
step. 2.6 moles
so
of sodium. This is 1 mole of sodium is what? 23 grams. That's all you need to do. So it's just like multiply 2.6 by 23. That's all you need to do. Just multiply the grams by the number of moles you are given. Because normally it has to be 1 mole at the bottom. So 23 times 2.6 is what you need to do. And that will give you your answer.
Yes, okay.
All right. That's why it's 59.8. There's 20 seconds. Good. Excellent. Everybody got this right. That's fine. Keep it up. All right. This should be straightforward because it said equal volumes of SO2 and O2 gas at STP contain the same number of molecules. Not electrons, not protons, not grams. You should know that. It's the same number of molecules. That is, you're talking about Avogadro's number. 1 mole, molar volume. 1 mole of any gas contains the same number of molecules. Okay. Nobody got it right. Okay, let's see the trick. The mole ratio in by mass. Mole ratio by mass. Carbon and oxygen. Carbon dioxide. Carbon dioxide and oxygen. Oh, sorry. Carbon and oxygen. Oxygen is diatomic. What is the mass of carbon?
12,
12. What is the mass of oxygen? O2.
32,
32. Very good. All right. So they now ask you what is the mass ratio. So 12 to 32. What do? We have to reduce them to the lowest term. Let's start with 2. 2 goes in 12.
16.
6. 2 goes in 32. 16, right? We can still go up further with 2. 2 goes in 6. 3. 2 goes in 8. 16. 8. That's the lowest. That's 3 to 8. It's very simple if you follow the instruction. Just read the question. Mass ratio. So just put the element on ratio form. Look at the mass. Oxygen is 32 because 16 times 2 is 32.
There's 2 of those.
Good. So, and this is 1 carbon. So when you have 12 to 32, try to reduce them to the lowest term until you cannot go further again. And that is 3 to 8.
Okay.
All right. That's why the answer is 3 to 8. Good. Wow, this is distributed 1, 1, 2, 2. Okay. Now, which 2 samples of gas at STP contain the same total number of molecules? If you look at this, 1 liter of CO and 0.5 liter of N2. This is 1 liter, this is half liter. They don't contain the same number of molecules. This is 1, this is half. This is 2, this is half. This is 1, this is 2. So this is 2 and 2. They have the same number of volume. So they will contain the same number of molecules. So that is 2 liters of H2 and 2 liters of CO2. Just simple mathematics. Here's another tricky question. This is the same similar problem to the previous one. At STP, 3 times 10 to 23 molecules of SO2 occupy the same volume as what? Now, this 3 times 10 to 23 molecules is the same thing as half mole of that substance, because 1 mole will contain 6.02. So if it is 3, then it is half. So which of these will be half? It's only 0.5. That is mole of hydrogen. This one, 6.6 times 10 to 23rd molecule is 1 mole. 4 grams of helium of hydrogen has 2 moles. 1 mole of hydrogen is 1 mole, but this is half mole. So it's just 0.5 mole of hydrogen. We have the same molecules. Remember, every gas contains the same number of molecules, 6.02 times 10 to 23 power. They have the same molecules for 1 mole. All right? This is a similar problem. Check it out. Which gas contains this? This is half of a molecule again. You have to be careful. This is half of a molecule. So, if you look at, let's start with hydrogen. The molar mass of hydrogen, atomic mass of hydrogen is 2 grams. 2 grams of hydrogen is same thing as 1 mole. Nitrogen has 28 grams for 1 mole because nitrogen is 14. And you have a subscript of 2, that is 14 times 2, give us 28. So this is half mole. The rest are just 2 moles. 38 grams of fluorine is 2 mole because 1 mole of fluorine is 19 times 2, which is 38. 1 mole of chlorine is 35.5 times 2, which is 71. So all these are 1 mole, 1 mole, 1 mole, except this, which is half mole. You have to be careful.
Mr. A.
My bad, Mackenzie. We was over here trying to solve out the freaking problem, but you finally were able to do it to get in.
I don't know. I'm on the chat. I can't see the question on Kahoot.
You can't?
Oh, I just see 4 squares.
Click on his. Oh shit, I gotta click my answer. Click on his. Fuck, dude, I don't even fucking know.
I'm dead.
Okay, so you just gotta click on his and click the little thing and it'll pop up so you can see it. Oh, why should we get this wrong?
Yeah. That was crazy.
Oh my gosh. Oh, I got it right.
Okay, you got it right. You just guessed, right? Okay, what is the appropriate approximate percentage by mass of potassium? Just like we did the other day, the other time. We have K HCO3. And we're looking for potassium. All right? You're looking for potassium. This is 39 plus 1 plus 12 plus 48. That is 3 times 16 to give us 48. The total should be, is that 100 again?
Yeah.
Okay, 100. So for potassium, it's 39 over 100 times 100%, which is 39%. All right?
All right.
Okay. Sean, welcome on board for the first time after how many weeks?
I'm dead.
I was about calling your parents again today because I said if I didn't see, in fact, I'm going to call many parents this afternoon. Many, especially this third period. Third period has not been coming on board. Unlike for my fourth period is always full. Most of the time I have 70-80% attendance. But third period, all right, how many liters of chlorine gas is in 25.5 moles? .5 moles of chlorine. I'm looking for liters. So these moles will also be here, moles of chlorine. Since I'm looking for liters, remember 22.4 liters equals to 1 mole of any gas. 22.4 liters equals to 1 mole of any gas. So if I have mole here, that means I have 1 mole here. And here will be 22.4 because I'm looking for liters. So the mole will cancel the mole. So what I have left is just 25.5 times 22.4, which is going to be is going to be 25.5 times 22.4, going to be 571.2 liters of chlorine. That's it.
Hey, Mr. A,
Yep.
what do you think is an easy way to remember that it's 22.4 liters?
So what?
Like, what's an easy way to remember that it's 22.4 liters if you don't have your notebook?
So how do you want to remember that?
Yeah, okay, what's an easy way to remember it?
Easy number. What do you mean?
No, easy way to remember it.
Oh, well, the easy way to remember is just to know that it's 22.4. There's no other way. Because once you're looking for liters, if you are looking for volume, you say, what is the volume of so gas? The first thing that comes to your mind is 22.4. It's the constant. It doesn't change. Excuse me. Just like Avogadro's number. This is molecules. Every 1 mole of a substance contains this. Every 1 mole of a gas occupies this. These are constant. Definitely, they will be giving you a question. Anytime you have a question like that, they will give it to you as a formula sheet. They don't expect you to remember, to memorize it, but it will help you if you know it offhand, because you may not have chance of going back to check your formula sheet before you continue with your problem. 22.4 liter is molar volume for any gas. Any 1 mole of a gas occupies this volume. Just like any 1 mole of a substance contains these particles. Any 1 mole contains these particles. Any 1 mole of a gas occupies 22.4. That's the only way to remember that. And since you're looking for volume, the first thing that comes to your mind is my molar volume. My molar volume is 22.4. That's what I will use to multiply the number of moles I'm given. This question is just one step. 22.5 times 22.4. That's all. You don't need to even think of anything. They don't normally give you balance equation on this molar volume. If it is a volume, if it's a molar volume like this, you don't have any equation to show for that. It's always one step.
Okay, because 22.4 showed up like last second, but I didn't have time to do the math, so I just guessed.
Oh, okay. Don't you have a calculator with you?
Yeah.
Oh.
But then I wasn't thinking of using it because I felt like I felt like actually trying to remember it instead of using the internet to help me out.
Oh, okay. All right. Wow. When you see law of conservation of matter, what comes to your mind when you see the equation?
Matter.
For
Has to
everything
be
to stay the
balanced.
same.
Balanced equation. They have to be balanced on each side. They have to be equal.
So that's how you know?
Yeah. If they're asking you for
Yo, I'm not even lying. I was gonna choose blue.
I'm dead.
Because it says like, okay, GA is there. F3, like whatever. Oh my god, I hate this.
which chemical equation follows the law of conservation of matter? That means which one of them has equal matter, equal elements or compounds on both sides.
And that's the same thing as being balanced, right?
Yes, that's the same thing being balanced. Just look at which equation is balanced. That's what they're asking you indirectly.
Okay.
Just look for a balanced equation. That's all. You just count the number of atoms on both sides.
Gotcha.
Okay. Right, a compound has a molecular formula NO2. Its molecular formula could be the same thing because any other one is not the same thing as NO2. NH4O2 is not empirical. N4O4 is not empirical. And you cannot change this NO2 to N2O. So the only option that is correct is NO2. Remember, empirical formula can also be the same thing as the molecular formula. I give you an example. Remember, I give you an example of sodium chloride. Sodium chloride is NaCl. It is both empirical and molecular. So sometimes the same formula can be both empirical and molecular. It's a similar question. Wow. Who got it wrong? Be sincere with yourself. Who got it wrong?
That was me, but I was an accident. I swear it was an accident.
Why? What happened?
I meant to, cause I was rushing. I didn't have enough time, so I just put anything.
Oh, okay. All right. This is a common proportion. You don't have to walk long distance. Come on now, this is a common proportion. You don't have to walk through long distance. What is the total number of moles of CO2 produced when 1 mole of C2H6 completely reacts? Now, what we're trying to say here is this. If Look at the question first. CO2 and C2H6. C2H6 is 2 moles, CO2 is 4 moles. This is ratio 2 to 4. 2 to 4 means 1 to 2. 1 to 2. 2 to 4. And if you change it to 1, if you change the 2 to 1, that means you divide by 2 to get 2 moles. So it's just like reducing this to 1, and this becomes 2. Just simple proportion. If you still want to walk through the long process, let me take you through that. C6H6 plus 7O2 to give you 4CO2 plus 6H2O. One mole 66H6. How many moles of CO2?
Call from 2348036760647. Call from 2348036760647.
Okay, so we have that.
Call from 2348036760647.
And we're looking for how many moles of CO2 do we get? Mole of this, mole of 6C2H6, that's the mole ratio is what? Is 2. And we're looking for CO2, that's 4 CO2. Mole of this, we cancel mole of that. Just looking for mole, so we just stop at mole ratio. 4 over 2 is what? Hold on. We're looking for CO2. Okay. Let me look at the question again. What is the total number of moles of CO2 produced when 1 mole of CO2 completely reacts? 1 mole of this completely reacts. C2H6. Yeah, you're right. Oh, that's correct. So that is 2, 1, 2. That will give you 2 moles of CO2, which is the same thing as just use your proportion. Just 1 mole is given the question, and the mole ratio of that C2H6 is 2. We're looking for CO2. So CO2 comes here with the mole ratio. And this 4 over 2 will give us 2 moles. That is if you want to do the long one. Okay, this is interesting. What is the total number of atoms contained in 80 grams of neon? Once you see your multiple choice question, responses, and you see this exponent, you know you're talking about Avogadro's number of atoms. So that means you have 80 grams of neon. Grams of neon will be here. Grams of neon. And what is the mass of neon? It's 40 grams on the periodic table. And this is 1 mole of neon. Alright? Since there is no equation, we don't need any mole ratio. So the next thing to do is to...
Wait, it's 20 grams, not 40.
Oh, sorry,
right?
20 grams. Thank you. 20 grams. Thank you. So you have mole of neon at the top. And since you don't have the balance equation, then you don't need the mole ratio. So the next thing to do is to use your Avogadro's number, which is 6 points. So 1 mole of neon at the bottom contains 6.2 times 10 to 23 power of molecules. Grams of neon will cancel grams of neon. Mole of neon will cancel mole of neon. So what you have left is 80 times this divided by 20. So this is like 0 cancel 0. This is like 4. It's like multiplying 4 by 6.0. Remember, this is 1. So we can just do that. We can just multiply 4 by 6.02. Sorry. 4 by 6.02. That will give me 2.4 times 10 to 24th power. Yep, 24.8. So that I'll have to move decimal point 1 step. That will be 2.4 times 10 to 24th power of that. That's how we got that.
For some reason, instead of like multiplying it by Avogadro's number, I divided it because I was thinking the opposite way.
Oh, okay.
But then, like, I didn't see the answer choice, and then I was like mixing things up.
Oh, it's always good to look at the outside choice before you make your decision on what to use. Once you see those numbers there, you know, oh, my answer has to end up with Avogadro's number. And that's why it has to be at the top. Because if you are given Avogadro's number at the question, then the Avogadro's number will cancel out. All right? All right. Who doesn't understand empirical formula again?
Can you explain it?
Huh?
Can you
What was the
explain
question?
Which of the following is an empirical formula? You don't know empirical formula? The one that has
Refresh my
the
memory.
simplest ratio number.
Oh.
C2H4, you can reduce that to C1H2. That is a molecular. C4H8 can also be reduced. C2H2 can also be reduced. So all these three are molecular formula. But CH is the simplest ratio. That is the definition of empirical formula. The one that has the simplest ratio. So CH cannot be reduced again to anything. That is the simplest form of it. All right?
Okay.
Bye. All right. Let's go back to class. What is the total number of liters of oxygen gas at STP? We're looking for number of liters now. An equation is involved. So let's see how do you do that. You have 0.5 moles of KClO3 given to us. And you want to find out how many liters of oxygen. Okay. So we're looking for oxygen. That's the question mark. Oxygen. Liters. So, since equation is involved, we have to use our mole ratio. So moles of KClO3 will be here, which is 2. What are we looking for? Looking for oxygen. So 3 moles of oxygen will be at the top. And because we're looking for volume, liters, all right, that means we have to remember that 22.4 liter equals to 1 mole of any gas. So if moles of KCl cancel moles of KCl, moles of oxygen will be at the bottom here, which is 1 mole always. And that is 22.4 liters. 1 mole of a gas occupies these 22.4 liters. Mole of oxygen will cancel mole of oxygen. So what you have is 0.5 times 3 times 22.4 divided by 2. And that will give us 0.5 times 3 times 22.4 divided by 2. Give us 16.8 liters of oxygen. That's it. 16.8 liters of oxygen. 16.8 liters.
When I said I was looking for oxygen, I multiplied by 3, but I forgot that you had to include the mole ratio.
Mole ratio, yeah.
Yeah.
Yes. Okay. All right. Okay. 0.55 moles of NO2. What is total mass? Straightforward. 0.55 moles of NO2. We're looking for mass. No equation, so no mole ratio. So 1 mole be at the top, or be at the bottom. Mole of NO2, mole of NO2. Here will be your grams of NO2. So nitrogen is 14. Oxygen is 16 times 2, which is 32. 32 plus 14 is 46. So this is 46 grams. Grams of NO2. So the answer is now, you multiply 0.55 times 46. 0.55 times 46. That will give you 25.3 grams of NO2. 23.5 of NO2. All right. We're looking for percentage of oxygen in this compound. The formula mass is 74 grams. Oxygen here is 16. Can you please mute your audio, whoever it is? 16 times 2, because you have 2 oxygen needed in this compound. These 2 distributed on OH. So you have 2 oxygen, which is 32. So percentage is 32 over 74 times 100 over 1. And that will give us 32 divided by 74 times 100. Give us 43.2%. All right.
Can I ready up, please?
Who? Who's speaking? Okay, substance has the empirical formula of this, molar mass of that. this is you have molar mass equals to 360. Empirical formula C2O. Oh, let me see the screen. And molar mass is given at 360. Empirical formula is CH2O. And to get the molecular formula equals to empirical formula times N. And your N equals to molecular formula mass divided by empirical formula mass. And molecular formula mass is given as 360 over empirical formula mass, which is what you have to calculate, 12 plus 2 plus 16. That is 14 plus, that will be 30. Yep, 14 plus 16 is 30. Okay, so 360 over 3, 0, 0 cancel 0, and this is going to be 12. So our molecular formula now is going to be empirical formula 12, which is of course is CH2O, and that will give me C12, H24, O12. You distribute all these 12 on it. 12 times 1 is 12, 12 times 2 is 24, 12 times 1 is 12. So this will be your molecular formula. This is just a simple proportion. X3, Y6. To get your empirical formula, just have to reduce this to the lowest term, which is 1 to 2. 1, 2. So that will make X is 1, Y is 2. Just reduce 3 to 6 to 1 to 2. It's so simple. You have X3, Y6. To get your empirical formula, you reduce them to X1, Y2. 3 here, 1, 3 here, 2. That's all. And this will be your empirical formula, which is also written as XY2. You don't have to write the 1 if it is just 1. All right, so this is how it's going to be. 0.30 mole of SO2, because if you look at the options you are given, they are given in Avogadro's number. So that means this mole will cancel this mole. 1 mole of any gas or any substance contains these molecules. So 0.30 times 6.02 times 10 to 23rd power will give you that 1.8 times 10 to 23 power. Wow, awesome. That's good. That's great. But for those who are still confused, now go back to the classroom. You have C3H8 plus 5OO2 to give you 3 CO2 plus 4 water molecule. You are given 1.5 moles of carbon dioxide. You want to know how many moles of oxygen do you need to produce that. So remember the process. Moles of oxygen will be, moles of CO2 will be at the bottom here. This, because you have a balanced equation, this will be your mole ratio. All right? So the mole ratio of CO2 on the equation here is 3. The mole ratio of what we are looking for is oxygen, is 542 moles. All right? The question says, look for what? We're looking for, okay, just the mole. That's it. You don't need the step 1. That'll be step 2. So just multiply this by 5, divide by 3. So 1.5 times 5 divided by 3 will give us 2.5 moles of oxygen. Because we're looking for moles. So just one step. Wow, what's going on? Are you sleeping? How many grams are 0.125 moles of iodine? All right, let's go back to class. 0.125 moles of iodine. You're looking for how many grams is this? The mole of iodine will be here. All right? And this is 1 mole. Because you don't have any equation to get your mole ratio from. So 1 mole of iodine will be how many grams? Iodine is 127 grams. Remember, iodine is diatomic. So 127 times 2. 127 times 2 will give us 254. So 254 times 0.125 will give us 31.75 grams. It's as simple. It's just one step. I know most of you have probably forgotten that iodine is diatomic. That's why you didn't get it right. So 254 will be for 1 mole of iodine, which is I2. I2 is 2 iodine, 127 times 2 will give us 254. Then times 0.125, because mole of iodine will cancel mole of iodine. And this is grams of iodine here. So what you have is grams of iodine as the final answer. Now I have to skip that question because oh, okay. I think this is correct. I was thinking the question is not complete. Yesterday, I think I adjusted it. Yesterday, there was no grams given to them. So, okay, don't worry about that. Right, that was great. All you have to do is just multiply 0.125 moles of uranium, 1 mole of uranium at the bottom, the grams of uranium will be at the top. So 0.125 times 238 will give us the answer. That will be 29.75 grams of uranium. Right, if you check your notes, when we're talking about molar volume, I think I gave you the pressure and temperature at standard temperature at the STP. Standard temperature and pressure. Standard temperature is 273 Kelvin. Standard pressure is 760 torr or 180 m or 101.3721 kilopascal or 760 millimeter of mercury. Those are the values I gave you. So these are the constant, which is the STP at normal temperature, at standard temperature and pressure. The volume occupies 22.4 liters when you have 273 Kelvin at 760 torr.
Mr. A, does adhere mean like that? Like, is that, like, what does that mean? Like, relates to conversion of mass?
For this question,
Yeah, what does that word mean?
conservation of mass
Like,
means
does it mean,
a
like-
balanced equation. Which equation is balanced?
Okay.
Yeah. All right. This is the only one that is balanced in all the equation. So if you get it wrong, count again. You have to count the number of atoms. You have 4 aluminum on this side, 2 times 2, 4 on this side. 3 times 2 is 6 oxygen. 2 times 3 is 6 oxygen. Some of you are still getting it wrong. The mass ratio is hydrogen H2O, that is 2 hydrogen to 1 oxygen. What is the mass of hydrogen? 1 times 2, 2 grams. Mass of oxygen, 16. The mole ratio is 1,
5 by 2 is 8.
1 to 8.
Oh, Mr. A, it's almost time for your 4th period.
Yep, I'm meeting them by 1:30, so I will finish this one with you. Don't worry, I'm watching time too. You have about 6 more questions. We'll move faster now so that we can get to the end of it. All right, which two samples of gas at STP contain the same number of molecules? We have talked about this before. This and this have the same number of molecules. They are the same, 1.5, 1.5. The rest are not the same. All right? All right, at STP, all these gases contain the same molar volume. They contain 22.4 liters at 1 mole. All right, how many peanut butter and sandwiches could be made from 8 slices of bread and 1 jar of peanut butter? Of course, who is this person who doesn't know how to make sandwich bread? You have 8 slices of bread and 1 jar of peanut butter. You use 2 slices of bread to make 1 sandwich. So you're going to have 4 sandwiches. This has 2,000 points. It's double points. This is limiting reactant. You take your time. All right, that's good. Except that, there's an error there. I think I made a mistake on the answer choices. The answer is supposed to be 1, supposed to be only 4 mole. All right, this is what it's supposed to be. You get your 4 mole of hydrogen. This is your balanced equation. Mole ratio of hydrogen is 1. You are producing 2 moles of HCl. So 4 times 2 is 8. When you use the chlorine, you are given 2 moles of chlorine. Balanced equation, 1 mole of chlorine at the bottom. You are producing 2 moles of HCl as a product. 2 times 2 is 4. It's because this is the smallest amount you can get. This is the amount you can produce. So your answer is supposed to be 4 mole. You cannot get this. So the answer is supposed to be 4 mole of HCl. So that's my error. I'm not supposed to click. I think I was doing some adjustment and I clicked 2 answers. All right, the only answer there is 4. That is, anyway, somebody got this right, but this is not correct answer. If you are the one who chose 2 moles, this is not correct. The correct answer is 4 moles. All right, take note of that. This one is straightforward, just from the previous page. What is the limiting reactant here? Great. At least 5/6 is good enough. The limiting reactant is chlorine. From this equation we just did, chlorine produces the smallest amount. That's chlorine. Produces the smallest amount of HCl. That is the limiting reactant. So this is your excess. We quickly go to the end of the game. Great. Magnesium has the greatest. So let me just show you what I'm trying to do. What I have to do is to the total mass of barium oxide is 137 plus 16. So the mass of oxygen is 16 over 153. For calcium oxide is 16 over 56. For strontium oxide is 16 over 104. For magnesium oxide is 24 over 40. So when you find the percentage of each one of them, let me see what we have. 16 divided by 153 will give us 10.4%. 16 divided by 56 will give us 28.6%. 16 divided by 104, 104 give us 15.4%. 24 divided,
It's 16.
16. 16 divided by 40 will give us 40%. So that is why this is the highest. 16 divided by 40 give us 40. All right. All right, to the last question, but not the least, 40 over 40. This is 2 points.
Is it SO4 instead of SO5 or
A2, Na2SO4, sorry. It's
Okay.
SO4, not SO5, sorry. SO4. Right, that was a good one. So the final review, Diana third position. Yay! Gabriel second. And the winner is Lexi. Congratulations, everybody. Everybody in the house. You get 20 points for your grade today. Choose any grade you want to use your 20 points for. Now,